Okay, ready to rock and roll.
Okay, perfect. So we'll just skip right to 3. Which hypothesis involves equality? That's the null hypothesis. And then 4, and when computing the p-value, which hypothesis do you assume to be true? I also put null for that one.
Yeah.
Okay.
Is there one that we assume that the alternative is true? I didn't see one in the reading, but I was.
I don't know. I think it's just like the wording in the question, like if it says decrease or increase.
Gotcha.
Okay, 5. Which of the following represents the alternative hypothesis for a two-tailed test? And that's the one I put.
The third one?
Yeah, the third one.
Okay.
Okay, and then a left-tailed test is the first one.
So the mean is less than
10, yeah.
Yeah.
And right-tailed test is when the mean is greater than 10.
Okay, wait. So 5 is which one? I'm sorry.
The third one.
The third one. Okay, sorry.
Okay. Do you need 6 and 7, or do you just need to go to 8?
We can just go to 8.
Okay. So which relationship would result in failing to reject the null hypothesis?
The p-value is greater than is that the sigma, or what does that stand for?
Are you talking about, yeah, I think it's sigma.
Is
sigma, and I don't know what the other one's called though.
This test something?
Yeah,
Test something. So I put the first one.
Yeah. Okay. And then which relationship would result in rejecting the null hypothesis?
If the p is less than the sigma.
Mm-hmm. So the second one. And then 10, which of the following would be the appropriate alternative hypothesis? I put the third one.
Third one? Okay. That's what I got.
Okay. And then which of the following would be the appropriate null hypothesis? Put the second one. But it might be the first one now that I'm thinking about it.
I think it's the first one.
It is too. That would be rejecting if it was the second one.
Yeah.
Okay. Then 12, the insurance company assumes the distribution of the sample means is normal. Is this a good assumption? Let me read this again.
I put the first one because the sample size is greater than, I think it was 30.
Yeah, I had that too.
Yeah.
And then these ones always trip me up, but I think it's the law of large numbers.
So I think it's the central limit theorem.
Might be. I always get mixed up.
Yeah, the law of large numbers. I know this because I missed it on the test. But that one's when the population mean and the sample mean get closer. But the central limit theorem is when you have a large enough sample that it makes it normal.
Gotcha. Okay.
Statistics. I can't even say that word.
So that one's Z.
Z, yeah. I'm in a statistics class and I can't even say
it. Okay, so we have to find the Z score. Okay, so This one would be, I'm just gonna like say it out loud to make sure I have it right. So this would be 144 minus 150, right?
Mm-hmm.
And then you divide it over 40 divided by the square root of 36.
Yes.
Okay, if that indeed is true and I did it right in the calculator, it's negative 0.9. So that seemed like a weird z-score to me.
Sorry, just one more thing.
Good.
So what did you get?
I got negative 0.9, but that seemed like a very odd z-score, so I might have typed it in wrong.
Okay, because I got something a little different.
What did you get? Let me try to do it again, but what did you get?
A negative 0.367.
0.3673. Okay, let me try it again. So you took 144 minus 150, right?
Mm-hmm. So it gives
And
you a
then
negative 6.
6. And then I've just switched my calculator.
40 by 36,
And then, okay.
which is
I'm gonna do this on this calculator. I might need to run and grab my calculator. Okay, and then you took 40 divided by the square root of 36, and then divided top by bottom. I think if I remember it right, my calculator, I can run and grab it, but I think I remember I got negative 6 over 6.666 or something.
okay. So I got like 16.3299.
Okay.
But
Let's go with yours, because I must have just, I know it's formula, but I must have just typed it in wrong.
Let me try it one more time. 40 divided by 2. Yeah. So I got a negative 0.367.
Okay, and then okay, perfect. Let's just go with that one. And then to get the p-value, you plug the z-score in, so negative 0.367. And you're just going to shade the left side, right?
I believe so.
Okay, I think so too. And for that, you get 0.567 if you round.
Wait.
0.3567.
Oh, okay.
Yeah, sorry.
Okay.
0.35.
So why do we just do the left? Is it because it's the negative?
So in the wording, as far as I understand, it says the store manager suspects that her average has decreased. And
Gotcha.
so when we write out, like step 1 is writing out the null and the alternative hypothesis, you'll see that the alternative hypothesis is left-tailed. So you'll just shade the left.
Gotcha.
If it was like the other way around, you would shade the right. I just kind of go, like, I just shade whatever the greater less than sign points to.
Gotcha.
That's how I remember it. Okay. And then for 17, it would reject the null hypothesis because 0.357
is greater than
greater than
that one. So you would fail to reject it, right?
So
because you reject it if P is less than the sigma. I think. Let me double check that.
Yeah, now I am not sure. I thought it was fail to reject because her null hypothesis thought it had.
Yeah, so it is fail to reject.
So it is fail to reject?
Let me just check one thing.
Okay, I thought it would.
Yeah, so if P is greater than sigma, we fail to reject.
Okay.
But if P is less than, then we reject.
Okay, great. Okay, and then 18. What is your conclusion for this problem? Would be the third one?
Yeah.
You failed to reject it? Okay.
So we have insufficient evidence to the population is less than 150.
Okay. These are two types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null hypothesis? It's true.
These ones, I have to read it like 10 times to get these.
I need to pull up the reading for this one.
Me too.
Because it has that good like graph in there.
Yeah. Can I find that?
Was the graph in the reading or was it just in the video? Do you remember?
I think it was in the reading because I copied it from somewhere.
Okay, yeah. So, okay, if it's saying rejecting the null hypothesis when the null hypothesis is true, so it's a type 1 error.
Type 1?
Yeah.
Awesome.
Okay. Then a researcher decided that instead of using a level of significance of sigma equals 0.5, he will use sigma 0.1. Okay. Okay, so I have to think about this.
Yeah, so it's in the reading. I just found it. It says, if the sigma value is very small, the probability of committing a type 2 error will be large. And then vice versa, if the sigma is very large, then the probability of committing a type 2 error will be very small.
Okay, so it would be the second one?
Yeah.
Okay, and then walk me through how you do this one. A 0.05. Compute the probability. I remember reading that.
I'm not sure. I think it's just 0.05, but
okay. I don't even remember reading how to
I
figure.
know. There's. Okay, so we. Because in the reading, it gives an example of the sigma 0.05 is equal to 1 over 20.
Oh, okay.
But if you do that, it gives you the 0.05.
Okay, I'll put that and I'll go ahead and submit it and see how we did.
Okay. Oh, did you make the recording live? I can't remember.
I did, yeah.
Oh, awesome.
Okay, we missed 15 and 16. And that's it.
Okay. 15 and 16.
So those were the computing numbers, the
Oh.
score and the p-value. So what did you guys, let me just make sure I had it typed in. I had 15 as, was it negative 0.367?
Yeah, that's what
Okay.
I put.
And then 16, I had 0.357.
Yeah.
Okay, so yeah, both of those are wrong.
Those
And
are
then
wrong.
that's
Okay.
it.
Well, let's look at that again.
Okay, I need to run and grab my calculator. Sorry.
No problem. Oh, what the?
I'm not sure where we went wrong on that one.
Oh, I pushed. Yeah. So when that was a stupid mistake. The square root of 36 is 6.
Right?
I put when I pushed the square button instead of square root.
Aha.
So that's where that makes a big difference. Yeah.
Figure out what happened.
Yeah, you were right. I put when I when I went to find the square root of 36, I pushed squared instead of square root.
Oh.
So
All right, so it's 144 minus 150. And then 40 divided by the square root of 36.
it's usually 6.666666.
Okay, so it is 0.9. A negative 0.9.
You were right. I'm sorry.
No.
Negative 0.9?
I just thought that was such a weird z-score. Doesn't that seem like a strange z-score?
Yeah.
And then, so if we still shade the left, the p-value is 0.184.
So 0.09, you said?
Negative 0.9.
Oh, negative 0.9.
Yeah.
Gotcha. So that gives you
184.
184, is that right?
Yeah.
Yeah.
Awesome.
Hopefully that's right.
Yeah, I'll submit it.
What else it would be.
Yeah. Yep, that's right.
0.9. Okay, great.
Nice job.
16.
Okay. Do you want me to read off the answers real quick?
I'm sure who's like writing all of them down. Sure, hold on. Let me just do a new quiz. That would be a lot faster.
Okay.
Hold on one second. Pulling it up here. Darn. Sorry, it's taking a second to load. Okay, so 3 is A.
Yep.
4 is A.
5 is C.
5 is C.
6 is A.
Okay.
7 is B. 8 A.
Okay.
9 is B. Then 10 C. 11 A. 12 A. And then central limit from for 13.
You're right on that one. It led us astray.
And then the Z. And then negative 0.9, 0.184, then fail, and then C for 18, type 1 for 19, B for 20, and 0.0.
Perfect. Awesome. Thank you for going over that again.
No worries.
Okay, cool, guys. Well, we will meet again on Monday.
Okay, sounds good.
Awesome. Have a good
Good
weekend,
luck on the
guys.
test.
Thank you. See you
Yeah,
guys.
you can do it.
Bye.